everyone, welcome to the channel Knowledge of. Friends, subscribe to the channel and click the bell icon for the latest update. Today we're gonna start with your computer-based numerical and statistical technique, which has been the CBNST, and that has been your 39th class of the session we have to discuss here. In these classes in CBNST, even though we had started in the last classes, which has been the unit 1, which we had completed, which is the computer aided numerical and statistical errors and rules of equation that we had in the last classes. In computer based numerical and statistical technique, we started with unit 2, which has been the name of the unit is Interpolations and Curve Fitting. And in today's class we surely will end up with this as well. And so before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So we go ahead and we'll discuss about the short answer questions, that is of 2 marks possible questions. So the question first we have is for the same is write an equation for Lagrange's interpolations. So we go ahead for equation for Lagrange's interpolation. So for that we'll have to talk about it, and that we have as follows. So yr, as I told you many times here in the when we are going to solve it out, the formula I had told you, yr equals to xr minus x1. जिन्होंने वो formulas नहीं लिखे हैं, वो classes नहीं देखे हैं, please go ahead with this, but I write it down all these the Lagrange equations of Lagrangian interpolations. xr minus x2 till xr minus xn upon x0 minus x1 x0 minus x2 till x0 minus xn, which has been y0, your y0, plus xr minus x0 upon xr minus x, that has been your x2, and x1 minus x0 and x1 minus x2, which is xr minus x3 till xr minus xn whole upon x1 minus x3 and x1 minus xn, which has been y1, plus xr minus x0 xr minus x1 xr minus x3 a whole upon x2 minus x0 x2 minus x1 and x2 minus x3, that is we have for xr minus xn upon x2 minus xn, and that is for y2, plus that will goes xr minus x0 xr minus x1 till xr minus xn minus 1 upon xn minus x0 xn minus x1 till xn minus xn minus 1, that we have. This is for the equation for Lagrange's interpolation that we have to discuss here. Now we talk about for the another question that we have here and on the same phase, which has been write an equation for the Newton's divided differences interpolation. So we go for the same equation for Newton's divided differences interpolation, that we talk about it, and the formula for the same here is for Newton divided differences formula, yr equals to y0 plus xr minus x0 y x1 x0 plus xr minus x0 xr minus x1 y x2 x1 x0 plus xr minus x0 xr minus x1 xr minus x2 y x3 x2 x1 x0 plus xr minus x0 xr minus x1 till xr minus xn minus 1 y xn minus 1 till x0. So we go ahead further, which has been another question, and that we have here is to define shift operator E. Define shift operator E that we have. So on the same phase, and that we have as follows as well, is E fx equals to fx plus h, and E inverse fx equals to fx minus h as well. Now we talk about the another question that we have here is define forward and backward difference operator. Define forward and backward difference operator. So that we have to talk about it, which has been forward difference operator is fx equals to fx plus h minus fx, and backward fx equals to fx minus fx minus h. So the another question we talk about it that has been asked, and which has been of course the important one here, and that has been what is the relationship between E and forward difference operator. So we go ahead. What is the relationship between E and forward shift operator? So for that we have E equals to 1 plus forward operator, and E inverse equals to 1 minus backward operator that we have. So we go ahead for the next, and that what we'll have to discuss here, which has been another one. Write an equation for fitting a straight line, and that we have. So sum of n I equals to 1, yi equals to naa plus b, and I equals to 1 xi. So we go for the next, that has been another question. What is the purpose of cubic splines that we have to discuss here? So what is the purpose of cubic splines? So cubic spline approximation cubic spline approximations cubic spline approximate third and higher degree polynomial for a given data. Now we talk about what is a piecewise linear interpolation. So for that, what is piecewise linear interpolation. So in that, a linear polynomial is interpolated for the two data points in an interval is called piecewise linear interpolation. So we go ahead for the another one that has been another important question, and that has been what is Gram-Schmidt's orthogonalization procedures. So I just write it on first here. A linear polynomial is interpolated for two data points in an interval is called an interval is called piecewise linear interpolation. Now we talk about for the another one what has been is Gram-Schmidt's orthogonalization procedures here. So the another question we have, what is Gram-Schmidt orthogonalization procedure? So for that, it is used to obtain orthogonal polynomials for the given intervals. It is used to obtain orthogonal polynomials for the given interval that we have. Now for the next we talk about it, which has been another one, and that what we'll have to discuss about it. Write an equation for T4x Chebyshev's polynomial. Write an equation for T4x Chebyshev polynomial, and for the same it will be for T4x, it will be your T4x equals to 8x4. So we go ahead for the same, and that has been 8x4 here. So 8x4 that we have minus 8x squared plus 1. Now we go ahead for the next, and that is what is Langzor's economization of the power series, and that what we'll have to discuss here. So we go ahead for the same, that being the next question we have here. And what is it is Langzor's economization of power series that we have. So for that will be Langzor's economization is used to decide number of terms to be considered in approximations of series for a given error here. So for the same we talk about it. So here Langzor's economization is used to decide number of terms that has been the numbers of terms to be considered in approximation of series for given error that we have discussed here. Now we talk about the another one, which is being the using Lagrange interpolation, find the polynomial through 0, 0, 1, 1 and 2, 2. So for the same we did that, and that's what we'll have to find it out. So here we go, using Lagrange's interpolation, find the polynomial through 0, 0, 1, 1 and 2, 2. So for the same we go ahead, and that what we'll have to find it out. Here we go, Lagrange interpolation formula that is given here is as follows: yr equals to xr minus x1 xr minus x2 upon x0 minus x1 x0 minus x2 y0 plus xr minus x0 xr minus x2 upon xr minus x0 and x1 minus x2 y1 plus xr minus x0 upon xr minus x1 and x2 minus x0 x2 minus x1 y2. Putting values in this above equation, we get yr equals to xr minus 1 xr minus 2 upon 0 minus 1 0 minus 2 into 0. So for the same we go ahead and that we talk about it. So here we go, plus xr minus 0 xr minus 2 upon 1 minus 0 and 1 minus 2 into 1, so that we find it out for the Lagrangian interpolation and the polynomial through this, and that what we'll have to discuss here. Now we'll represent that here for the same, and after that plus xr minus 0 xr minus 1 upon 2 minus 0 2 minus 1 into 2, which is equals to xr, replacing xr by x, where y equals to x. So this is true since values of x and y are same. So this is true since values of x and y are same. Now we talk about the another one which we have to discuss here, that has been the another question. So if fx equals to 1 upon x square, find f a comma b and f a comma b comma c by using divided difference. So for that we talk about it. Here we go ahead, that since divided differences up to the third order is required and the three values of x and fx are required, so they are known here, which has been as follows. X, and this has been or fx equals to 1 upon x square. This has been 1, 2 and 4. Here it is 1, 0.25 and 0.0625. So here the divided differences that will show here, and that what we'll have to talk about it, and that we have to go ahead. So we made a table for it, that we go x fx f xn minus 1 and f xn minus 1 and xn minus 2. For the same we talk about it. Here we go. So the same 1, this has been the 1, 0.25 minus 1 upon 2 minus 1 equals to minus 0.75. Here for the second one, 0.25, it will be your minus 0.09375 minus 0.75 upon 4 minus 1, and that will be giving you equals to 0.21875 here. Now we talk about for the next, the same phase that we discussed here for fx n minus 1 here, that we have 0 minus 0.625 minus 0.25 whole upon 4 minus 2, which is equals to minus 0.09375. Now we go for the fourth one, that will be 0.625 for the fx. Fourth one is 0.625 here. Now go ahead further, which has been the another question, and that has been the last question of the sessions as well. We go further. So for the next question is being that we have here, find the polynomial which takes the following values that we have for x and y. For x we have 0, 1, 2. For 0 it will be, you have your 1, 2 and 1. Okay, so for the same here, that the Newton's are backward and forward differences that can be used, and however, since polynomial is required, it will be easier to use Lagrangian interpolation. So we go ahead. yr equals to xr minus x1, xr minus x2 y0 upon x0 minus x1, x0 minus x2, and for the same it will be plus xr minus x0, xr minus x2 whole upon x1 minus x0 and x1 minus x2 y1 plus here xr minus x0, xr minus x1 upon x2 minus x0, x2 minus x1 y2. Putting values in the above equation, which has been yr equals to xr minus 1, xr minus 2 upon 0 minus 1, 0 minus 2 into 1 plus xr minus 0, xr minus 2 upon 1 minus 0 and 1 minus 2 into 2 plus xr minus 0, xr minus 1 upon 2 minus 0 and 2 minus 1 into 1 which will be equals to xr square minus xr square plus 2xr plus 1, and that replacing xr and ayr by x and y respectively. That will be give you y equals to minus x square plus 2x plus 1. This is a required polynomial which we required of. And now we go ahead to end up with, but here that the concept flow chart, I told you that interpolation being divided into four, which has been your 7 category, which has been the finite differences operator and cubic spline interpolation, Lagrangian interpolations, Chebyshev's polynomial approximations, Newton divided differences interpolations, Langkos economizations, and the piecewise linear interpolations as well. In curve fitting, that has been divided into the least square approximation, L conditioning in the least square, and Gram-Schmitt's orthogonalization. So here we're going to end up with, and we'll discuss from 40th class of the session, that has been the unit 3rd we'll start with. And other than this, we had done sociology and software engineering. We had done chemistry for class 11th and 12th for part 1, and even though for that we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, and unit 8, unit 9 with their conversions as well. And after talking about that, yes, we had dealing with ER diagram, we are dealing with English vocabulary, we are dealing with FNHP important questions as well. Even though we are dealing with chemistry part 2 for class 11 and part 1 physics for class 11th as well. And we are dealing with quantitative aptitude. In that we had started with arithmetical ability. In that we had done your operations on numbers, estimate analysis of numbers, decimal fraction, simplification, square roots and cube roots, problems on numbers, problems on ages, loss and indices, percentage, profit and loss. And now we had started with ratio and proportion. After other than that, we talk about it. Yes, we had done reasoning. In that we had done verbal reasoning, where in that general mental ability in the logic reasoning, and in non-verbal reasoning we had done your series analogy classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, road direction, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, and practice question set. Coming towards computer-based numerical and statistical technique, in that we had done unit 1, which is the computer arithmetic errors, floating errors, floating point errors, machine absecant round of error, chopping error, truncation error, associative and distributive law in the floating point arithmetic inherent error, error propagation, numerical stability. In roots of equation, we had done your second method, Newton-Raphson method, fixed point iteration method for a simple roots and derivations of their rate of the conversions, as well as your ethic and acceleration of conversion, modified Newton-Raphson method for the multiple roots, Birch-White method for polynomial, and Bystrom method for quadratic factor, and computer algorithm of these methods as well. After talking about that, unit 2, which we have to discuss about interpolations and curve fitting. In interpolation, we have done the algorithm and the error analysis of Lagrange and the Newton divided differences, interpolations, relationship invariance differences operator, piecewise linear interpolations, cubic spline interpolation, natural spline, Chebyshev's polynomial approximation, Langkos economization of the power series. In curve fitting, we have to cover up the linear and nonlinear least square approximation, L conditioning in the least square method, Gram-Schmitt's process of orthogonalization, computer algorithm of the least square curve fitting. In unit 3rd, we have to cover up the differentiation and integration. In that, we have to cover up the method based on the interpolations and finite differences, Richardson extrapolation. In integration, we have to cover up that has been the error analysis and the trapezoidal and Simpson method, Newton's Cotes integration method, Gaussian integration method, Gauss-Lagrange method, Lobato integration method, Radau integration method, and errors terms in integration method. Unit 4, we have to cover up the solutions of simultaneously in algebraic equation, which has been the cause elimination method, L conditioning system, condition number, successive over the relaxation method, rate of the conversion. In solutions of ordinary differential equation, we have to cover up the single step method, Runge-Kutta second order, third order, fourth order method, that is multiple step method, predictor, corrector method as well. In statistical technique, we have to cover up the statistical hypothesis, test of hypothesis, type 1, type 2 errors, levels of significance, tests involving normal distribution as well. So here we're going to end up with huge request to all the viewers to please go ahead with like, share and subscribe to the channel so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.